So we are looking now at an important factor. It's kind of my personal hobby horse. I really like to talk about compression set. Compression set is what makes your seal last a long time. And for most seal users, it's probably the last question that'll ever cross their mind. When compression set, people are worried about material, they're worried about price, they're worried about availability. Compression set is the life of your seal. So let's take a look at that. And what is compression set? It's not the ability, it's the inability of a seal to return to its original shape after being compressed. And I think earlier on we did use the terminology of fat Uncle Ernie or whatever I said, that sits on a cushion all day, and the cushion has got the back end of Uncle Ernie permanently crushed into the cushion seat. O-rings are like that. Any seal is like that. If you compress it for a while, there's fatigue in the molecular structure and does not want to come back to its original shape. So compression set is a value that's important because it'll tell you how much rebound over time you're going to get. And here's a little diagram just to make your life more amusing. So you deflect the part, put it under compression like this, and once you remove it from compression, you measure this part here, which is the difference between what you've compressed. So you've actually compressed this piece here, and you measure what comes back, and it's a percentage of what did not come back. So that means if it doesn't come back, remember we said that a good seal is a resilient seal, a seal that bounces back, it touches the walls, both walls that you're trying to seal up. Well, if it doesn't come back, then what you're starting to get premature leak paths. And most materials that you can buy over the marketplace, your supplier slash manufacturer slash distributor should be able to give you the compression set numbers. So and the compression set number, the higher the number, the worse the material. So if you have a 60% compression set, that means 60% of the original squeeze you put on the part, which is this part here, never came back. So it costs you nothing to ask for those numbers, but it makes all the difference in the world if you're looking for long-term sealability. So there's my little editorial for today. Different surface finishes that are yielding the same RA value. That's kind of technical, but the RA value measures, and we will take a look at the diagram, what an RA value is, what a surface finish value is an average of the difference between the peaks and valleys of your surface finish. So what this diagram there is trying to show you is that you could get a very knife-like surface finish on the edges, very cutting, or you could get a sort of, well, it's squared off. It's not rounded off, but it's squared off. But this one is going to be murder on seals compared to this one. Yet, if you're just using a surface finish value in the RAs, it's kind of like running the mile. You can run the mile on a flat surface, you can run the mile uphill, or you can run the mile downhill. And I don't have to tell you which one is easier to do, but yet it's still a mile because it's just a distance value, and so is this. Typically, if you're using honed surfaces, you'll usually get more acute peaks and valleys than if you're using a skive and roller burnish finish, which is a little smoother on the edge. Just food for thought on surface finish. Okay. Now, if we go back to friction, something very important. If you're using a high friction seal, like we saw when we looked at the different profiles, going from pure lip seals to pure squeeze seals, the more friction, the more heat. So you need to keep your material in line with the amount of friction you think you're going to get. And I did mention before, or at least I think, getting old, sometimes I forget, but we've seen up to 20-25 degrees Celsius more on high friction seals at point of contact, just because of the buildup of frictional heat. Okay. Of course, heat causes vibration, so you get the noise, and there's something interesting. We find that a lot of the repair shops and some end users mention more and more, your seals are noisy, they're noisy, there's vibration, I can hear the cylinders are squealing. Well, when you get that, well, you know it's excess friction, so you have a choice of seals. Noise. Oops. We're practicing your French on this one. Must have slipped my mind, but you get where. And so friction, yeah, friction is not a bad thing. We love friction when we need to hold loads. We need friction when we need excellent sealability. But there's in areas where we don't want friction. So remember, we go back to that first slide. We say, what's your temperature? What's your pressure? What's your fluid? And what's your application? So the application becomes very important, because the application will tell you if friction is more important than sealability, if wear is more important than friction, and then it's sort of for you to decide or to ask what's better in given circumstances. But at least you know you've got the option on the seals you choose to go one way or the other. Sealability. Well, we sell seals, so I guess it makes sense that sealability would be a great factor of interest here. Pressure aids sealing. So regardless of whether you're using a squeeze seal or whether you're using a lip seal, the more pressure you add, the better sealability you're going to get. You're just on a lip seal, it's the parachute syndrome. As you send pressure between the lips of the seal, it pops open, and the more pressure you get, the longer and the harder it stays open. And it's on a squeeze seal. Well, the squeeze seal seals at zero pressure, but the more pressure you add to the squeeze seal, it's going to deform and it's going to add more squeeze. So pressure definitely aids sealing. And remember, a lot of our leakage, people say, oh, seals, the problem with seals is it's always at high pressure. No, the problem with seals is low pressure. Because a lot of the sealing issues we get are low pressure. High pressure brings us extrusion. Low pressure brings us poor sealing ability. So we like to think that pressure is going to give us a hand. Most sealing problems occur at low pressure, and you can have that argument over supper or with your work colleagues at the lunchroom. Everybody will tell you, no, it's high pressure. I tell you, most sealing problems, they happen at low pressure. Why? Because there's not enough pressure in the system to push the seal, to open it up and make it effective. Right? So the pressure increases conformity on seals. There's another great truth for this morning. Extrusion. So extrusion, this is a high pressure problem. We say, oh, we get leakage because of high pressure. No, you don't get leakage at high pressure, you get extrusion at high pressure. And what is extrusion? Ability of an elastomer to bridge a clearance gap. A lot of your dynamics mean that you have one piece sliding into the other. Now, if you want one piece sliding into the other, that requires that you have a certain gap. Do I have time to take this baby apart again and show you? Be patient with me. Say if I want this piston here to slide into the bore, you know, there's got to be a bit of clearance in there, because if there's none, then everything jams into place. And we like to chuckle on this one, but if you're going to make parts at zero clearance, then you don't need a seal. But I digress. Okay? Yeah. So you've got that gap between, example, the piston in your tube, or you would have the same thing on the rod end, where there's got to be a clearance on the head between the gland and the rod. Well, that little clearance gap, if you start adding pressure to it, the seal is gonna bridge the gap. So it's gonna have a tendency to get pushed out of its groove, or to get deformed through just that little part. You know, we said extrusion, it's kind of like icing a birthday cake. You know, you got your pouch and you're pushing that big blob of icing over a little hole to give it a shape. Well, that's the good extrusion, but what we get on seals is a bad extrusion. So we want to minimize the ability of the elastomer to bridge a clearance gap. So you've got a few ways to do that. And extrusion problems, they're pretty simple because they're based on three factors. You know, extrusion is caused by you have too much clearance. Now, in most catalogs, the manufacturers will tell you how to machine your grooves, what your tolerances are, etc. So, excessive clearance when you don't use the book. Excessive pressure, you're running pressures that are over and above what's recommended by the manufacturer, or somebody's telling you a lie. Not that it would happen in this world, but you know, they have the right information. So you have excessive pressure, excessive clearance, or your material's too soft. So we have different hardness ratings on the A scale, the Shore A scale, which is a rubber scale. Typically in our business, it's 70 or 90 hardness are the most popular ones. So as you increase your scale, you get a harder material. And when you go to the harder material, you know, you're gonna clear the problem of insufficient material hardness. And as the material hardens, it will have a certain ability to bridge the clearance gap. Being a harder material, it's going to resist that being able to get pushed through. Right? Of course, the downside to having a material hardness that's too high is, remember we said that a resilient seal or a good seal will conform. Well, when you increase material hardness, you're winning on one side on extrusion, but you're losing on one side on sealability because your material is too hard. I think it's like that hardened squeegee in the wintertime at your gas station. You're trying to clean your windows and the rubber part is hard as a rock. Then it's hard to clean your windows properly. So same thing in the rubber business. I mentioned that we have rubbers in the Shore A scale. We also have plastics that are on the Shore D scale. So some of the high-end polyurethanes, when you get into PTFEs, Teflon's the brand name that you'd recognize, but PTFEs, etc., they're also much harder. They're measured on the D scale, and there's a point where the Shore A and the Shore D match, but it's that information's available. We've got the literature to tell you where they meet. Like, you know, if you want to compare a rubber band or a bowling ball or the heel portion of your boots, and they all line up somewheres between the A and the D scale. But it's as you increase the numbers, you increase the hardness, and when you increase the hardness, that's what you're taking care of your extrusion. And remember, and I'll probably never say that enough times, so I'll say it one more time. I might have said it before. I'm getting old, so I repeat myself. Seals are a question of compromise. It'll always be a compromise. What you win on one side, you're going to pay on the other. So you want to increase your sealability, so you're going to soften your material, because we said that the softer material conforms better, it's a better seal. Problem is, if you soften it too much, then it extrudes. So you're going to harden your material and the opposite happens. So life is like that. I think every decision you make is a question of compromise. Good to know. I didn't answer anything, right? I just told you it's a question of compromise. You decide. There you go. That's my way of doing things. Well, we told you everything there is to know. Now you decide. I hope that helps. Okay, other important concepts in sealing performance. Okay, this is what happens when you get extrusion. You'll find if you get an old part and there's a tail that wasn't there in the first place, and all of a sudden it appears, you're probably getting extrusion. That seal is being pushed through that clearance gap here, and material gets pushed out. Yeah, I've never seen one in real life that's that bad. I think they machined that thing just to make it look horrible, but that's still telltale of what you'd get. Okay? Pressure and clearance gap between hardware will result in something like this. And it's promoted. It's not caused, number one, but it's promoted by dynamic motion, because as either the seal, whether it's a piston or a rod seal, as it moves, it has a tendency to be pushed. The dynamic motion along with the pressure is the first culprit, but the dynamic motion keeps on pushing that edge right through the gap, and then you get those new legs that weren't there before. And it, of course, as this gets caught between, example, a piston and a tube, or between a gland and a rod, as this gets jammed in that extrusion gap, generates additional heat, because that causes friction. It gets stuck in there. Kind of like when you don't clean your the jar of honey you've got at home, and you forget to, so it generates more friction because you didn't clean it off. Well, same thing. When that gets caught in there, it generates more friction. And heat equals growing compression set. That's pretty technical, but while we're at it, let's talk about it. Oftentimes, remember we looked at how to calculate compression set. It's the percentage difference between the initial compression and the residual once you take it apart. Compression set gets worse as the temperature goes up. So when those things happen, when material gets caught and your friction goes up, then your compression set kicks into high gear. And then the resilience you get up here starts to wane because it's been exposed to too much heat. So that whole extrusion thing is really very important. Biostability erodes. That's really technical. We'll pass on that one. But, that extrusion, you start, it goes out of the groove, creates heat, creates noise, creates all the problems. And of course, at the end, it gives you sealability problems. And you bought that thing as a seal, so it's nice to know that it'll hold up the sealing part of it. Okay? And what we're trying to show here is just as your rod, or this is in case of rod, but you could look at it the opposite. You could think that that this is a this is a piston, and that's it. But this is a rod. So as the rod extends and retracts, it's actually creating dynamic motion on the face of the seal, and it wants it to either push it right through here or twist it. So that's the problem you get with dynamic sealing. So you'll get sealability issues, you'll get stability issues, you'll get extrusion issues. So nice to know that those things exist. And that's when seal selection becomes important, because there's hundreds of seals out there you can use. Which one's the best? Depends what you're looking for. And that's why we'll go back, pain in the neck, to be polite, okay? Temperature, pressure, fluid, and your application. Always go back to that first slide, because once you ask those questions, all of a sudden it opens up a can of worms of things to discuss with the customer, who will say, or the end user who will say, I would like a better seal. Well, what's a better seal? Well, what's a better day? You want a nice summer day at 30 degrees sunshine? Well, that's great if you're expecting a summer day. If you were thinking of going skiing, might not be the best day. So it depends what you're looking for. Same thing with seals. Get the parameters, get the basics out first, and then we can tool around and see what would best fit the application. Stability problem caused by a seal moving within the groove. Let's back it up here. There you go. So as the rod moves within the cylinder, it's pushing these seals and it's causing torsional movement as it moves forward. So if you're using a lip seal that has a lot of free space between the lips, I could have used a better one, but here's the baby. You got these, I don't know how well it'll show up, but you got these very thin lips and this very hollowed out center. I mean, this very soft to move. Okay, so when the torsion comes, it's easy to flip this thing. As you start filling up your material, like typically an O-ring here, well, the block itself becomes more stable because there's less free space within the seal. Now, the other problem we have if you're using O-rings, square seals are always better than round. That's why some cavemen years ago invented the wheel, easy to turn. Pretty cool though, huh? Think of the caveman who actually came up with the idea that something round would be easier to push. It's the same thing in seals. Okay? So, stability, that's what we're looking at. Seal width moves within the groove. And if I push the right key, how to cure seal instability? Square is better than round. Example on, I'll take a typical loaded seal. I like this one. It's purple. Purple with a brown O-ring. Isn't that amazing? Okay, well this one's rectangular. Okay, that means the cross section typically on this one is 1/4 inch, and it has a height or a width or a depth or whatever you want to call it of 3/8. So it's rectangular, but they also make these square where it'd be 1/4 inch by 1/4 inch. So we're saying square is already better than a round seal, but a rectangular seal is better than square. Always harder to flip around a rectangular seal rather than a square. Do you always need rectangular seals? No. Why? Depends on what you're looking for, right? Application, but it'll help you if you have seals that you think they're moving around the housing. I've even seen instances where you can hear the seals pop back. They've been flipped over by the pressure, and when you release pressure, you can even hear the seal pop back. It's into the proper shape. That's a stability problem, and then there's rectangular seals. There's other ways to cure, but that's. And here, what we have here is a couple of things. Here you have a lip seal, okay? And as you see, you're looking at your gap. This is your standard gap, and people ask, what's your gap? Well, gaps are nice when they're concentric. When your gap is the same on the top as on the bottom, and most of your equipment never works in a perfect vertical position. They always work in, somewheres around the horizontal or tilted. So what you end up getting is oftentimes you're fine here, you're at zero clearance. Hey, life is wonderful. But then you took that clearance here and you removed it from here, so it's removed, but it's added double up here. So your risk of extrusion is twice as bad here as it was before. So what we do in that case, what we suggest, you might be familiar with wear-rings or bearings, these wonderful nylon or polyester or PTFE bands that we use on pistons and in glands. And of course, they're called wear-rings because, I don't know why they're called wear-rings, because it's better to have these wear out than having your metal-to-metal contact, so they take care of the wear. One of the big things that wear-rings do, and that's why people also call wear-rings guide rings, because what they end up doing is they remove the eccentricity problem. So as soon as you install the guide rings, then your clearance becomes equal on both sides. So that's why it's a twofold. Guide rings are twofold. So they'll cut the metal-to-metal contact with the risk of scoring, because they're the ones who are going to take the scoring, and they keep your parts centered. So we've done a few things here, okay? We've added these guide rings. What is my guide ring doing? Well, it's keeping my parts concentric to avoid having mega extrusion on one side, okay? What we see here is the risk of extrusion. Oh, well, they've added an anti-extrusion ring, which oftentimes we would just call it a backup. But then again, it adds material to block that off. So we're doing a few things here based on the problems that we get in dynamic sealing, which is extrusion, stability, and at the end, when you're starting to get this, your sealability goes out the window, and then when you start getting extrusion, then you get friction, and then you get wear. So there are all these little devices that are available, and I don't expect you to have that down pat by the time that this little presentation is done, but if you would only keep that first slide that I've been hammering into your brain about temperature, pressure, fluid, and application, we already have a good start. And then we have a start for discussion, and then you can discuss with your engineers, with your shop supervisors, with your seal supplier, with your end user about what they're trying to accomplish and where there's been issues. But we're just trying to show you where seals are efficient and when they're not. Other important concepts in sealing performance. Surface speed. Okay? The problem with, and again, we did discuss before about the compromise, you know, what you get on one side, you don't get on the other. So let's talk about surface speed. As I increase my surface speed, I get hydroplaning. And if I lower my surface speed, I will get frictional heat. So let's discuss, okay? You're probably very familiar with hydroplaning in your car. If you're not using the right kind of tire, or if you're trying to get one more summer or one more year out of your old tires and they're starting to be as smooth as a baby's bottom, then what you're going to get is that hydroplaning is caused when your seal, in our case, cannot go through the film of fluid that we're trying to seal. So basically, between, example, a cylinder rod and the seal can't get through that film of fluid, okay, because it's not aggressive enough. So you get hydroplaning, and basically, what's hydroplaning in a car is that your tire is no longer in contact with the roads, in contact with the film of fluid, rain or snow or ice, and that's when you lose control. If your surface finish is really, really clean and you lower your surface speed, then you get more frictional heat, because as your seal moves along, as you lower the speed, then the seal has all the time in the world to clean up all the oil, all the fluid that's held within the surface finish. Surface finish is a bit of an oil retention tank. It's a very, very, very tiny tank, but just the fact that you can just basically having an oily rag just coats. And as you lower the speed, then there's no more coating, because your seal's had all the time in the world to clean it up. So, you know, which is better? Oftentimes, I can't tell you which is better, because your surface speed is going to be dictated by what kind of machine you're using. So your other choice is to change the type of seal you're using, whether it's the lip contact area or whether it's the material you're using. But you have to remember, surface speed is something to consider. Your surface finish, you've got thermoplastics and rubbers and PTFE and dynamic. Okay, so everybody loves PTFE, which is Teflon, because Teflon is self-lubricating, right? I'm sure it's still in there. My Guinness World Book of Records has got to be 25 years old, but PTFE was already in there as a material, the man-made material that has the lowest coefficient of friction. So we said in dynamic sealing, friction, heat, noise, vibration, the things we don't like. So let's all put PTFE in all our cylinders, in all our application. But PTFE is a plastic, so plastics have no memory, they have no resilience, and we said a good seal has to be resilient. So you'll see a lot of PTFE seals that are energized with a piece of rubber, or even sometimes we see them with metallic springs behind to give it that resilience. So, but PTFE is great when you got bad surface finish, because it lowers the friction. Um, you know, rubbers are great because when you have bad surface finish, they will conform better to those bad surfaces. Now the bad side is that rubbers being soft on bad surface finish, they're going to wear out fast. Now thermoplastics, and in there we could almost throw thermosets, which is like polyurethanes. Now polyurethanes are great at wear, and they're better than rubbers for wear. They're worse than PTFE for friction. So concepts and sealing performance. We're not telling you what's best. We're just throwing out, if it's slow, frictional heat. If it's fast, you get hydroplaning. If it's rubber, you get, I'm using the bad stuff. If you're using rubber, you get high wear. If you're PTFE, you get poor resilience because PTFE is a plastic. If you use thermoplastics, well, it's not as good as rubber and it's not as good as PTFE on certain parts of the scale. So it's really something, other important concepts. When you're looking for that application, think of all that. It's not a 2-hour seminar that's going to solve all your problems, but it's questions that you can throw out because there's probably a seal that'll fit that specific application. Need to know. Ready to go. Installation. So let's go back. A few things to think about. We look at cleanliness. Make sure your parts are clean when you put them in. And clean, that means if there's any metal shards or pieces of leftover machining that'll cut your seals or dirt. Cup protection from having to push this piston over a threaded insert here. You don't want the seals to bite into the threads and damage it. Like we said, some people use shim stock to cover. Shim stock's nice. Problem is with shim stock, when you break a piece, you got to go out and find where the missing piece went. There's also some fancy installation tools that are available where you can cover your threads, make something easier with a big lead-in chamfer to push through. Lubrication, nice to grease up your seals when you're installing them. It helps, but then you gotta remember that whatever you're using to lube is compatible with the seals you're using. I should have added that later. A lot of people use petroleum-based products, which are great when you're using polyurethanes and nitriles and stuff like that, but there's a lot of seals now in the industry that are EPDM based, and EPDM and petroleum products don't work together. The heat, a lot of people will heat up their seals because it makes them a little softer to install. Well, like I say, it's tricky because how much heat are you putting on? If you're putting too much heat, you're going to attack the molecular structure, and you'll only find out after premature failure. I'm sure a lot of mechanics out there have been doing the same trick for the last 50 years, so you know what you're doing. I'm always a little wary about how people are heating their seals, but I guess what you don't know won't hurt you. So, but you have to be careful, because we find a lot of the premature leakage. We see there's damage that was done on installation, so something to think about. Lip geometry, well, depending what you're trying to do. If you're using a rounded lip, it's easy to install. If you have a straight cut lip, like this one here, where you have a flat edge and an angled one, if you're going over threads, this one is really difficult. But straight cut is a great one when you're trying to eliminate contaminants in the system. So your lip geometry on a straight cut, if you look at this flat edge here, that's energized, okay? It's a great scraper. The material contaminants in your system will never get caught, okay? Because they'll get pushed basically like the ice scraper on your car, okay? The beveled, we're adding, like on this one, we're adding a secondary bevel. Hard to see, I know. It's what in the industry a lot of people call the type B. And the type B was called that way because it was called back beveled, but it's got that beveled. What it does, that beveled, it gives you a lot more unit load. So we're combating hydroplaning because we're generating a ton of force on a tiny surface right in the middle of where you get the maximum, we're getting the maximum preload. Okay. Square, if you're trying to replace a seal that's kind of rounded, the square will give you better stability. So you have to look at your lip geometry. And again, there's not a perfect lip geometry. Actually, the rounded, the straight cut, the beveled, and the square, they're all bad lip geometry if you don't use them at the optimum place. So again, what's your application? We'll start with that. And I'm not going back to that first slide. Said it enough times. But application, application. What do real estate agent people say? Location, location, location. I say application, application, application. You know, and people say he's a pain in the butt because he's always asking these questions. Yeah, but when you go see your physician and you're not feeling well, I think the doctor will ask you a whole bunch of questions, and he's not trying to be a pain in the neck, a pain in the pain in the other one will probably happen when he pulls out the big needle, but the pain in the neck is asking too many questions. Well, how do you get good answers? If you ask enough questions, and then that helps you. So, you know, all these things here, they're other important concepts, and they're all good concepts to think about, and they all have solutions. You just have to know what you're looking for, or you have to ask to find out what you really need to know. Okay? Media compatibility, we looked at it at the beginning, popped some seals into some non-compatible fluids, and you'll see oftentimes the results are pretty instantaneous. You'll get swelling pretty darn quick. So that again, media compatibility, I think all manufacturers, like we saw an example at the beginning of a fluid compatibility table, I think all manufacturers have that. If it's not a graph, it's a chart. If it's not published in a book, it's available online. And if it's not available online, or if it's not available in a book, then if you backtrack, if you go back up the ladder to your different levels of who supplied the part, somebody within the chain, the supply chain of vendors will be able to give you the answer. It's, when in doubt, it's good to ask. There's a lot of fluids out there that are called by a trade name by somebody who invented that in his lab last week. And so then it's a little bit of hunting around to find out, but that's very important. That's, you know, we've seen people, human beings that have awful reactions to either a product or a drug, something they ingested and they broke out in hives, or they got comatose or whatever. Well, some seals can get comatose too, except in their case it's usually permanent. So selecting a seal, so you think your shape first, okay? Is it a static seal? Is it a dynamic seal? So you start with that, and then what are you looking for? The shape, is it lip or is it compression? So we know that the lip seals will give you low friction, but it'll give you low pore sealing, low pressure sealing ability, but good wear. If you're going to compression or a squeeze seal, well, a squeeze seal will generate high friction, high wear, but it'll give you a high sealability. So right there, you know, you can kind of decide which way you want to go depending on what your application is. Select the material. What's the temperature range you're looking at? What's the pressure range you're looking at? And what kind of fluids are you going to seal? So you have to look at all those graphs we had at the very beginning of the presentation for your pressure, your temperature, your fluid compatibility. You're going to look at that. Capacity to retrofit. Here's an interesting idea. A lot of people will always buy the same seal regardless, because they know they have a weird groove dimension and there's only one brand of seal that fits in there. And that's the capacity to retrofit. Sometimes you get these old pieces of equipment, and whoever invented that groove years ago, well, there were manufacturers who'd made those seals, and now they've all gone bankrupt, or they've all closed down, or they were all bought up by somebody and they trashed the tooling. Capacity to retrofit, it's important to find out what the groove dimensions are, because the books will tell you in theory you should be using I've said these twice. I'm going to use a blue seal now, just for variety's sake. You should use these blue seals. These blue, well, actually, you'll say they're not blue, they're turquoise. All right. Aquamarine? No, whatever. But I can't get it in a size that will retrofit. So you have to look at that, because not every manufacturer has every size tool in every material and in every configuration that you're interested in. So sometimes you have to be careful. You know, if something looks like it's a bit of a weird size, double check, make sure the availability. The other thing I can say about the capacity to retrofit is that one of the big changes, I would say, I don't want to age myself, but you know, that started maybe 20, 25 years ago, but that's really that it's kind of, it's like people who don't own a cell phone, and you could ask them, how could you ever get around without using a cell phone? Well, a lot of seal suppliers now have CNC lathes made specifically to manufacture custom-made seals. So, you know, that seal that you couldn't get because it wasn't tooled anywhere, well, now you can machine it. So the capacity to retrofit nowadays becomes a lot easier, because everybody has those machines that can do a one-off. Of course, if you're buying 10,000 seals and they're all machined, you might find they're expensive, so maybe you might want to tool up. But I'm just saying, capacity to retrofit now becomes less of an issue than it was 10, 15, 20 years ago, just because of all those fancy Haas lathes that are spinning around in North America, machining seals to your exact dimension and in a variety of materials. But something to think about. Special requirements, they could be anything. You could be selling to the nuclear industry and they're going to ask you for a material that is compatible with the nuclear grade, and oftentimes you can ask what those parameters are and they'll tell you, I'm not going to tell you the parameters, I'm going to tell you the nuclear grade spec. You have to meet that spec, so you have to be able to supply a certificate of conformity that says that it meets the spec. And that's an important thing. Sometimes a special requirement, there's things that are done here, they want it in kit form, and we here in the industry we do a lot of kit bagging. You want that seal, but you want it with all the other parts to go with it. Sometimes they'll say, we want that seal specially wrapped because it's going to be kept in a warehouse for the next 20 years, and we don't want the lighting and the ozone and the UV and the dirt and everything else to age the material prematurely, so they'll ask you for special packaging. I don't know, we even had one, I still have it's a very tiny instrument, so I never bring it out for video and stuff like that. It's one of those things you got to pass around. But I got a tiny little O-ring on a plunger on a little hydraulic actuator, and it has to be green because that's what the manufacturer wants. He wants it green. Doesn't want it white or purple or orange or black. It has to be green. What can I tell you? No? Price. Whoever spoke about price? That's not important, is it? And availability. I think price, we are the 17th today. We are the 17th of May 2022. And in Montreal, all the dealer lots for new cars are empty. So you want to buy a new car? Guess what? There's no cars out there. Yeah, but I've got the money. Yeah, you got the money, but I don't have the car. So price and availability nowadays, and I'll throw an example at you that I know. We have some manufacturers who lead times, if they don't have the parts on the shelf and nothing's in production, it's 46 weeks before they put it in production. 46 weeks, like that's almost a year. Add your summer vacation and your Christmas vacation, that's a year. So you can choose the best seal in the world, you can't get it. So price and availability, we put them at the end because they're always, There's always, this guy makes them, you can get it anywhere, you can go to the hardware store, they have them. Oh yeah, but I went to the hardware store, they're 3 times the price now, and they're 8 weeks to deliver, or 12 weeks to, so that's a factor too, when you select the seal. You try not to use something that's so exotic that every time you have to order, they'll ask you for huge minimum quantities or huge lead times. So we try to stay within the standard, but sometimes the standard doesn't work because you've done your homework. Remember the one I said I'd never ask you again, like what's the temperature and what's the pressure and what's the fluid and what's the material. So maybe you found that perfect seal. Nah, you kind of have to put this in perspective, especially in 2022 where everything is blamed on supply chain issues. You know, that's the best excuse in the world, right? So keep that in mind next time somebody, oh no, I don't have a, how come you don't have a supply chain issues? Isn't that a great excuse? I don't know when you'll listen to this. Maybe if you listen to this in 6 months, what was he talking about? It's all taken care of. Okay. Think shape first, lip, squeeze, your shape at the area at contact. So do you want a back bevel lip? Do you want a square lip? Do you want a round lip? Depending on what you're looking for. Friction, seal, the friction of the seal, the contamination resistance, etc. You know, you got your contact area shape. If you want good contamination resistance, you know, then you got some that are good and some that are bad. This very high and this high, it's because you always have a flat edge here, okay? So the contamination that's being pushed through the system can't get past this barrier because it's square cut or straight cut. This one too. So is this the best seal? For this, yes. Is this the best seal? Tendency to hydroplane? Not very good. So you've got seals that are good for film breaking ability, like these back bevel lips. They're great to be able to, remember we said hydroplaning, you're trying to push the seal lip right through the film of fluid that builds up either on your cylinder bore or on your cylinder rod, okay? And because we're generating a lot of force under a tiny area, well, it gives you a high film breaking ability, okay? But is that what you're looking for? If you have a tendency to have a noisy cylinder, you might want to keep that film of oil, because that film of oil will stop the squealing. So you're not going to use a type of seal that's got a high film breaking ability. So you have to put everything in perspective. And again, what's the best seal? Depends on the application. So you can look at your film breaking ability. That's one way to do it. Your contamination exclusion, we looked at these. Tendency to hydroplane, then again, it depends on the shape. And it'll give you here typical uses. Pneumatic U-cups will get a rounded lip, because oftentimes in pneumatics, the problem with pneumatics, you're not sitting in a pool of self-lubricating fluid like oil or things like that. So, you know, your pneumatic U-cups, you want them to be able to kind of glide. And so if you round your edges, they kind of roll over the surface finish, give you less friction. Wipers and piston seals. Well, wipers and piston seals, you're really trying to keep the contaminants out. You don't want contaminants to get stuck between the seal and the cylinder wall on a piston. And a rod wiper, well, the job of the rod wiper is to exclude. That's why they call them excluders. You want to exclude the contaminants out of the system. So you need to have these very aggressive lip shapes. Rod seals, it's the opposite. Rod seal, you're really trying to avoid hydroplaning. You want those rods to come out of the cylinder really dry, because when they're really dry, that means if you're working on earth moving equipment, well, you don't want sand and dirt and mud and dust to get stuck on the rod, so you don't want to have it oily, greasy, drippy, whatever. So you want a rod seal that's going to make sure as the rod extends out of the cylinder that it's really cutting through that film of fluid. So you've got different things to look at, and they're all very important, but they're all, I would almost say, they're all mutually exclusive. So you can't say, I mean, I'm sure there's one seal that you'll probably want to use because it will do 80% of what you're looking for with reasonable performance, but sometimes you're looking for more than 80% reasonable. You're looking for 100% perfect. So you have to look at what makes it tick and what your parameters, what is the best thing you would like in a seal, and then you can look at it. But even that seal, where it touches, becomes important. So we said think shape first. Well, that's part of think the shape. Okay, do you think your material? See, anticipated performance. I'll go back to my hobby horse. Let's go back to compression set. Compression set, those values talk about the life of the seal in service. What kind of performance you're looking for. I have customers that need something that's good for 3 days, for 3 hours, for, I've got an application, it's an O-ring, but it's got, I think, 23 minutes to work. After that, it's too bad. So, you know, that's the performance. I have some seals that the spare parts or the seals in service, they want minimum 25 years. So they're different parameters. What is your anticipated performance? You go in some areas where, I'll give you an example. We have a company that machines carbon fiber parts for planes, and the carbon fiber, once it's finished, it has to be perfect, unblemished. And they had an issue with the machine, a milling machine, and one of the rod seals was, after a while, it would form a drip of oil. Well, you get these big sheets of machined carbon fiber, you get a drop of oil and they scrap it. So what's their anticipated performance? I mean, it's got to be perfectly dry. Yeah, it's going to be a little noisier because it has to be dry. I can't afford putting thousands of dollars of carbon fiber in the garbage because I get one drop of oil. So this guy's anticipated performance, he'll tell you what he wants. He wants an absolutely perfectly dry rod seal. Somebody else will say, I can't stand the noise. If I get a few drops of oil, we'll catch them, but I want to make sure my seals are constantly lubricated or even to excess. So everybody's got something different. Well, I don't know how you like your hamburger, but I don't like ketchup in mine. If you like ketchup in yours, that's your anticipated performance. Mine is, I can't stand ketchup on a burger. So, to each his own. What's your anticipated performance? Your sealing parameters? No, I'm not going to go over. You know what they are. Or you can go back to the beginning of the seminar. What makes a good elastomer? I don't know. The good elastomer is the one that fits your application. You know, what makes a good pair of pants? I've had nicer pants, but these are pretty comfy. I'm not going to fashion show today, so they will do for the day. Okay, so what makes a good elastomer? You know, good elastomer, you have to go back to everything we talked about. The good elastomer is the one that fits your application. It fits in the P word and the T word and the F word. You know, I said I wouldn't repeat them, but you get the F word is fluid, just in case you have a twisted mind. Okay, what's the true cost of a seal? And that's where it becomes important. And you know, we talk a lot about how much do they cost? No, I say no, it's not how much do they cost. It's how much are they worth? How much are they worth to you? Okay, take a look. Hey, you can buy the seal. So, you know, we put price at the bottom, and for somebody who's buying 1 million pieces a year, yeah, maybe that half a cent per piece on 1 million pieces, maybe it makes difference at the end of the year, but you got to buy it. So we're buying a seal. Preparation cost, let's say you're working on a cylinder where you can't retrofit, okay? So preparation, you have to machine a new groove because you can't get the right seal. Well, I can tell you right away, unless it's a really fancy seal, the seal cost is way less than having to remachine grooves. So right there, but you have to add those two together. Then, what's the installation cost? And preparation and the installation, taking it apart, putting it together. We have areas where we have cylinders in, I'll use the extreme, but when we get into hydraulic servo motors, which are basically large cylinders used on hydro turbines to operate the wicket gate system, they're installed up on the wall in down in the pit where the turbine wheel is, and on top of the whole turbine wheel sits the alternator. I mean, those things weigh tons and tons and tons, and when that cylinder seals fall apart, I mean, preparation, installation, when you have to remove everything, that's hours and hours of fun and games. So how much is your seal cost? How much does it cost to replace when you've had to take the whole machine apart because the original seal didn't really match the sealing parameters that were required? All right, warranty cost. So you did a repair, the seal didn't hold up, customer calls you up, I don't like the performance, is this on warranty? Yes sir, it's on warranty. Good, I'll send you the unit back tomorrow. So you'll do it because he's a good customer and you're proud of your work, which is fine, so you're going to do it at no cost. That original seal that didn't hold up, how much is it worth? You're redoing a whole job under warranty and you're getting nothing in return. Why? Because maybe it was that O-ring in there that's worth 23 cents, didn't hold up. So what's the cost of the seal if it doesn't perform? It's this, plus this, plus this, plus this. I should be a car salesman. Put everything drastically. Oh, if you don't buy this high performance car, you're gonna wrap your car around a telephone pole and you're all gonna die. No, okay. Replacement cost? Well, when you're doing a replacement, because it didn't function well, you usually do it no charge. But if you're replacing a seal with another seal, there's worse expenses than that. Your downtime. Now here's something interesting. We have seen applications in other business, but we've done a lot of work with turbines and turbine seals for hydroelectric stations, and we've had to do some replacing over the years. Not so much because the seal didn't last. Let's say the application wasn't, the contractor didn't do it as they should have, and oftentimes that's all done under warranty costs. During that time that a turbine isn't running, they're not selling electricity. So that downtime, if they're charging so much per kilowatt hour, that's revenue stream that's not coming in because either of that or because of that. And we've often had our local utilities, when they run into that snag, they see we're going to be nice guys. So what do you mean you're going to be nice guys? Well, we expect you to change all that, but we won't charge you for lost revenue of what we weren't able to sell while our machine was down. But that is huge. The town, we often use that a little bit flippantly. Oh yeah, think of downtime, think of downtime. Yeah, when your machine's off, you're out with your excavator and you're charging the customer $800 per hour to operate that, okay? And it's sidelined for 3 days. That's a lot of hours at $800 an hour. And so, think of, you have, I hate to say think outside the box, but it's not outside the box. You got to think long term, you got to think down the line. What happens if you got to factor that in the true cost of the seal? All right, so here we say when in trouble. What is trouble? A lot of the times is you get that call of somebody who says, can I get something that's better? When they ask you for something better, you're already in trouble because it's better to what? better in seal life, better in price, better in friction, better in, so when in trouble, here's a few parameters, a few things to look at when you're faced with, we're not sure what we should put in there. No, that's what I call trouble. Okay, so look at your seal selection process, because a lot of times customer calls and he says he's in trouble because he's not getting the performance of the seals that he's anticipating. So you got to look at the seal selection process. We went through all that before with all the first 4 points at the beginning, and then we looked at the surface contact, we looked at extrusion gaps, we looked at friction factors, we looked at a whole bunch of stuff. So you're going to go through that, make sure we understand where we're going. But that's on the seal side. Okay? Customer's got to look on his side too. Examine the complete system. As an example, you go to your tire manufacturer, to your tire supplier, it says they're bad tires because it's not holding its air. So they check if you have a nail or a bad valve or something. Now you find out it's your rims that are rusted, so you can't hold the air. Well, it wasn't a tire problem, it was the complete system, it was the wheel itself. So you have to go one step further. Is his system properly adjusted? Or is his are the tolerances right? Are the pressures the way they should be? You know, is the use they're doing with the cylinder, I mean, is it used properly for what it should be doing? So you gotta check, you know, did they purge the air out when they put it together? This one's what we like. Remember we had that picture of that orange seal when we were talking about extrusion, had that big tail on the end. That's, there you go, you can tell right there it's extruded. The failed seals will often tell you a story. If you have metal shards.
Attention, restaurant Sailors à la réception.
Comment on fait pour
Quand tu l'arraches, tu prends le...
Pour la prochaine fois, on va se renseigner.
Non, tu prends le fil.
Juste faire examine fill.
Ouais. So we've got examine failed seals for symptoms here. The failed seal, if you look at it closely, will often tell you a story, or at least parts of a story. Remember that orange seal we looked at when we talked about extrusion? Had that big tail on the end, which proves the material's getting pushed out there. You know it's an extrusion problem. You know, with the size of that tail there, your gaps are probably huge. Well, always keep your failed seals when you're not sure. They're a good indicator. Sometimes you get these seals, they're baked, they're hard, they're crumbling. Well, you know you have a heat problem. Now, is it a frictional heat problem? Is it an outside heat source? Is it just a bad selection? You know you're working at this temperature, but you elected, or somebody chose a seal that wouldn't make it that high. So keep your failed seals. They're great for analysis. You know, that's why it's always better when you can actually go see your physician when you have an issue. You know, it's hard to describe them over the phone sometimes. So keep your failed seals if you have questions. Okay, get qualified help, and get qualified help. You know, you could be your seal vendor. It could be the repair shop that's working for you. It could be your manufacturer that actually build. It could be in our realm here, in which we are authorized distributors. We could take it one step ahead. We can backtrack it to the manufacturer. So there's always somebody within the loop that knows a little bit more, and don't hesitate, because it's always cheaper to get the real story than to keep on changing seals all the time. And remember what we said about the true cost of the seal. You don't want downtime, you don't want warranty costs, so you might as well bite the bullet at the beginning and find out what the real problem was, and use all the qualified help you can get. Installation, we discussed a little bit about that, about the problems with installation, but check the following points. Seal hardness. Remember we came back to this purple one, and it's hard, and I can use something of the same size, and here little me, I can bend this one, but I can't bend this one. So seal hardness for installation. Should always buy this one, right? Because it's easier to install. Oh yeah, but what happens if you need the hardness of this one for your pressure resistance? Again, we go back, you know, it's a question, you choose one and you choose the other. But you have to look at that for installation. And it's always nice to get the softest you can, as long as it'll hold up the pressure and it'll hold up the wear, the friction. Okay. Seal configuration. Okay. For installation, there's, again, I'll go back to this purple seal. It's nice. It's got that nice flat side with the bevel lip, so it's good for scraping and stuff like that. But because it's good for scraping contaminants, when you install it, it's also good for scraping itself against the threads of a barrel. So, is this, it might be the best for contamination resistance, but it's probably the worst for installation. So, which one's the best? Depends what you're looking for. But think of your seal configuration. You know, we said maybe a rounded edge is not the best, but maybe it is the best because it's the seal, it's the only one you can install without having too much friction and a damage of the seal running over the threads. So, hardware dimensions, we go back to retrofit. Hardware dimensions, like we said before, with the question of retrofit back in the days, if you couldn't get that size, you were basically on a dead end. Now with everybody running these lathes, I'm sure, you know, the non-standard seal that's impossible to get can probably be manufactured in less than a week on somebody that has those quick turnaround machines. But it's nice to know your dimensions, because there's maybe another type of seal that would fit in there that's not the same configuration, but that will do the trick. So, gotta know for install. If you got issues, let's find out what those hardware dimensions are. I mean, the last thing you want to do is to modify stuff because you can't find the seal that goes there. Okay? It's always cheaper to get the seal than to have to modify the whole unit. You have to remember, in a lot of the applications, if you have to modify one or two pieces of equipment because you can't get the seals anymore, but you have 50 machines, that means you've got 2 machines that have this new hardware dimension that you modified to put a standard seal, and 48 others that aren't the same. So give us the hardware dimension. Might be easier to try to make something that fits in there. Hardware design, don't necessarily have an example, but you've got a piston here. That's one piece. A lot of customers, if the seal is difficult to install, to stretch over, they'll have a 3-piece piston. So 1 piece, 2 piece, 3 piece, and you put them together, and when the rod goes through, it gets bolted in. Hardware design changes are probably pretty expensive, but oftentimes it's easier to have a change in hardware design than to scrap seals, to damage seals repetitively. So that's something you can do too. Have different type of hardware. And seal failures, will end with this one. And thank you, since this is our last. No, I think the second last. We'll look. Anyway, we're getting close to the end. Okay, seals fail. We discussed what extrusion is. We said extrusion, your gap's too high, your pressure's too high, your material's too soft. We looked at a variety of ways to harden the material, to put anti-extrusion rings, to put guide rings, to, also to close up your gap if you can. Seals caused by wear, and it depends on the application. If you have long strokes or the wear, if you want 20-year service, well, wear becomes important. If you're retrofitting your cylinders every summer during plant shutdown, maybe it's not such a big thing because you're going to take them apart anyways. Contamination. Again, contamination, we said sometimes...
Attention, restaurant Marinos à la réception.
Contamination.
Okay. So for contamination, here's something that's interesting. Remember we said, you know, when in trouble, review the seal selection process. And then after that, we said to review the whole system. Well, oftentimes contamination, yes, it's a seal issue because it breaks down the seal, it gets stuck in the seal, it damages the seal. But the contamination, it comes from somewhere else. Something broke in the system at large. Something wasn't cleaned upstream. I've also been very surprised that when you buy fresh oil straight from the refinery, sealed in barrels, you know, we have some customers that filter that oil before putting it, but it's brand new, and they filter the oil anyways, and you'd be surprised to see how much contaminants there is in a fresh barrel of oil that you bought today, sealed, signed, sealed, delivered, but it's signed, sealed, delivered, and contaminated. So, you know, contamination can come from a whole bunch of places, but when we said examine your seals, you'll know right away if you have a contamination issue. You take your old seal, you look at it, hey, what are these shiny pieces? Oh, that looks like metal, or that looks like dirt, or this looks like whatever. So, seal failures, oftentimes contamination, and no matter what seal you use, if there's stuff that comes highly contaminated, and you can get harder materials that won't wear as fast, but the bottom line is you shouldn't have contamination. In these days of high filtration system, of this, that, and the other, your fluids should be clean. Fluid incompatibility, that's use your fluid compatibility charts as much as you can. Look them up, and then again, if you can't find, because all you have is trade name to work with, or all you have is something that's been discontinued, call. You know, you can call your distributor, you can call the manufacturer, you can check on the web, or even sometimes we'll run and we'll find a lab that'll help us identify what goes on the materials list, and try to find something that's pretty close to something that we know is going to work. So, heat. You have to be careful of frictional heat. We've discussed that. You have to be careful about where it's being used to get the right information. Sometimes the shop that repairs the cylinder is not aware of where it's being used, and therefore they're not using seals that will be able to resist the high temperature that the cylinder is going to see once it's in service in the bottom basement of a plant somewheres. So that's something you have to look at. So check your heat and try to find out. Again, it's application driven. Where is that cylinder being used? What are some of the parameters? What are some of the issues that you're having because of where it's being used? And that might be an indicator there on the heat. Okay? And non-consideration of relevant information. And that's why a good being able to diagnose it right, you get asked questions. And a lot of people say, I don't have time to ask all sorts of questions. Well, you're going to take the risk. You know, if your physician doesn't ask you what you're allergic to, you're going to say, oh, that's no problem. You know, I can break out in hives or I can die tomorrow, but I just need it now. I'm not sure you'd go that far. That's the same thing in seals. If you're not going to tell us, if I can't know all the relevant information for that application, makes it difficult to cover all your bases. Like you saw in the past, seal is always, seal selection is a compromise. It's what you're going to gain on one side, you're going to lose on the other. So it's, yeah, if you're in a bind, some people will use anything. They'll use duct tape if they have to. But really, when you're looking for something, what's the thing that you cannot do without? So what's number one on your list? That's the relevant information. So be sure you get to the bottom of it. And that's about it. We're not going to do any discussion because you heard me long enough, but hope this helps. And again, it's use your local Repair shop, if you're using one, use your local seal distributor like ourselves, use your manufacturer, or if you have a contact with this either the equipment manufacturer or the seal manufacturer, just ask questions. Don't take doesn't exist for an answer. Everything exists. You gotta put your mind to it. And I always think that choosing the right seal from day one probably saves you a lot of headaches in the long run. And that's all we're trying to tell you with this presentation.